How are you all today? Bright and chipper? Tired as can be? I see it both on your faces. How many of you have started off the dietary assessment and tried that out? Have there been any glitches? Okay, it's worked fine and as you had hoped and everything? Okay, good, good. There will probably be a few of you who are here in the class who weren't here before, so I'll mention a few things in just a moment about class requirements again. But what I'd like to do is start off by introducing our teaching fellows for the class. The teaching fellows have already sent you contact information and a list of the sort of tasks that they're going to be coordinating. But these are all graduate students in psychology, and they'll be assisted by several people working with me at the Rudd Center. And altogether, we have a really terrific team. So if you guys wouldn't mind standing up, I'll introduce you. So you'll put some names to faces. So on the far right is Christina Roberto. Next to her is Anna Neuheiser, Jeremy Shen in the middle, Ashley Gearhart, and Julie Wong. So, and then Allie Crum is one of the others, but she is unable to be here today, so we'll introduce her to you later. So let's give these guys a big hand. All right, now let me remind you that they're going to be grading many of your things, so let's give them another hand. I thought they might appreciate that. Okay, thank you guys. And you received an email, if you were on the class list yesterday, from Christina that talked about the class assignments and how they'll be handled by the various teaching fellows. And so if you have questions, and this will be on our website, it was in the email you were sent, and then it'll be here too when I post the course lecture notes. So contact these particular teaching fellows if you have questions about these particular parts of the course. And then if there's anything that can't get resolved that way, then go ahead and contact me. But the nice thing about contacting the teaching fellows is they'll be able to get back to you more quickly in all likelihood. And then in addition, because they'll be handling all the questions from the students, you'll be getting uniform answers. Now, by the way, when we do grading for the class, what we're going to do is to spread the grading around the teaching fellows so that everybody's work is going to get graded evenly by all the teaching fellows. So for example, the teaching fellows will divide all the concept sheets in week one, and one teaching fellow will grade part of the alphabet and another will grade another part of the alphabet. Then in week two we'll switch so that another teaching fellow has a different part of the alphabet, et cetera, and it rotate around. So if there's any systematic bias going on in the way these things get graded, it'll smooth itself out across the teaching fellows. So we'll have a fair grading system and things. So again, contact these folks if you have any questions about grading for parts of the class. Just a few reminders, if any of you are here for the first time, and I know there are a few, if you go to this particular website, and you can get to this from the class's server as well, you'll see the course website that we've developed, and it has a lot more information than if you just go to the classes server and click on the syllabus. That will contain some of the information, but not all. So I urge you to go to this. It'll talk about the course, its history, requirements for the course, and the like. Second is all the readings are available through the classes server. Has everybody been able to access them all right so far? Okay, good. No glitches with that. I also wanted to make a mention of how much level of detail I'm expecting you to remember from what you read. The readings will be a mix between things that will be quite easy for you to understand, things from the popular media, et cetera, and then some more sophisticated publications from scientific journals. What I'm looking for you to come away with when you read those scientific publications particularly are the big picture issues. So for example, the Jenkins article that I have listed up there was one of the readings for today. And they talked about what food does metabolically, and they talked about studies that would show, for example, that some foods have a different glycemic index than other foods, and they would affect metabolic outcomes like hemoglobin A1C. I don't expect you to learn that or even retain it unless I explain the concepts in class or unless they're explained quite well in the paper itself. My task in the class here isn't to do an in-depth analysis of the biology or things or scientific methods or anything like that that would make you have to retain a lot of detail in the readings. But mainly we're looking for big picture issues. And so if you get asked about these readings, as you will on the exams, we're not going to be picking and not expecting you to remember details and not expecting you to understand concepts that you can't just grasp from the readings themselves. So don't get too caught up in understanding the methods or statistics in a particular study or anything like that. If it's important enough for you to retain, I'll stop and pause on it in class and discuss it in enough detail so you'll be able to learn it. I also want to note that in the class we have a wide array of backgrounds. We have freshmen in the class, we have graduate students in the class. We have people from business backgrounds, art backgrounds, psychology, science, just about everything. So there will be parts of the class that will be easier for some than others. But overall, I'm not expecting you to learn a lot of detail, but mainly the big picture, as I said. And then finally, as you know, the first concept sheet is due next week, and any of those who are here for the first time can go to the lecture notes for last week, and it gives a detailed description of how to do the first concept sheet. Also today, one of the teaching fellows will be sending out a sample concept sheet, although you may have already seen it from the website. But in addition to that, a series of instructions. Actually, we're going to wait till next week to send that one out, and I'll explain why in a minute. But that will go out and it will give a series of instructions for how to think about the concept sheets. Now, the reason we're going to wait till next week is the first concept sheet is unusual in that it's not just you writing about whatever you want, but it's writing about your dietary analysis. But after that, it'll be writing about whatever you want, and sometimes people feel a little out to sea, not knowing exactly what we're expecting. So those instructions that we send out will be helpful. All right, before I move on, are there any questions about details of the class or requirements or readings or anything people are having trouble getting on top of? Okay, good. Well, looks like we're in good shape. Okay, the next thing I'd like you to do is get yourself a clicker. Now, those of you who've been in other classes where you've used these will know what these are, and you may even have the clicker already. But what the clicker is a little device that will allow you to enter responses to questions that will then get entered into my computer, and we can show immediate poll results from the class. It's really pretty interesting and nice technology. And these can be checked out at the Bass Library that's on the cross campus. There's no charge to students. I'm not sure if they make you pay a deposit, but I think you can just check them out. And then you'll have them for the semester. And the little clicker then, as I said, there will be an electronic device connected to my computer. I'll ask you questions like how many of the people in the room would favor this policy or how many would favor that policy. You pull out your clicker, you do it, and then we'll get a nice little pie chart or a bar chart on the computer of your responses. So it'll be a very, very nice way, rather than just a show of hands, on how people are supporting different policies. So what I'd urge you to do is to get the clicker as soon as you can, and we'll start using it fairly soon in the class. I'm going to do a few little quizzes today where we're just going to do a show of hands, but beyond that, the clicker will be helpful. And the clicker does not have any identifying information on it. So you're one of 300 people in the class or so, and your response will show up, but we won't know who it came from. So there's no intent to use it in any kind of way of identifying people. But it's a big help, and it's kind of interesting, instant reaction to things. We might see how the females in the class feel about some issue compared to the males. We might ask for people from the US and people outside the US. We might do things like that. That'll be pretty interesting. So please go get the clicker at the Bass circulation desk, and they should have enough for everybody in the class. Okay, now let's get to talk about nutrition. Now, of course, nutrition is the kind of subject that one could spend a whole semester on, do multiple classes on, because it's a very interesting, fascinating, and complex topic. And we're going to blitz through it like the 100-yard dash. And that means we can't stop and linger in too much detail on different topics, but I would like to give you some of the rudiments about nutrition, especially about how we measure nutrition, and then what it means for health. And we'll talk more about that in the next class. But it's a very interesting topic. So today we're going to talk about how do you measure what people eat, and you're having some experience that yourself with the Daily Plate dietary assessment. We'll talk about difficulty people have in understanding what a portion is. We'll talk about what a calorie is and what it means and how it's measured. And then we'll talk about macro and micronutrients. So here's a quick quiz, just to get your sense. I'm not expecting necessarily to get these right, but just to get a sense of a few issues with nutrition. So which of these things do you think is worse for your health, trans fat or saturated fat? How many of you would say trans fat is worse? And how many would say saturated fat is worse? Okay, I think I mentioned this in the early class, didn't I? So either you guys are listening or you know a lot. But you're right, trans fat is not good for you and it's worse than saturated fat. Now you may know that New York City and other places around the country have enacted regulations to stop trans fats being served in restaurants. And how much of a health improvement that represents depends in part on what the restaurants switch the trans fat for. And so if they switch it for saturated fat, there is an advantage. There is some improvement that will represent, but not nearly as much as if the trans fat is switched out with a healthier fat. So we'll talk about different kinds of fat and what that might mean. Okay, so which is worse? Polyunsaturated fat, monounsaturated fat, or both are pretty good for you? Okay, how many would vote for number one? Mono. And how many for poly? Okay, and how many would vote for choice C here? Okay, kind of an interesting spread. Well, the answer is choice C. Both are pretty good for you. Now, there was a time when people thought fat was bad. And people didn't really understand there were different kinds of fat, or they didn't realize that different kinds of fat had different impacts on health. So we'll talk about that more in the next class as well. But it was interesting to see the mix of opinion. Okay. Now, if we look at different approaches to weight loss, there are dozens and dozens of approaches. There's almost always some weight loss book on the bestseller list. And the question is, which of these approaches to dieting works the best? Okay? One would be a low-fat diet. One would be a low-carb diet, like Atkins. Another would be just a low-calorie diet. And then choice D is they all stink. All right, how many of you would say a low-fat diet is best? How many a low-carb diet? How many a low-calorie diet? Okay, and how many would say they all stink? Okay, interesting mix. The answer is they all stink. Unfortunately, weight loss diets don't work very well. And that's one of the reasons why there is always a diet book on the bestseller list. Because if anything worked, there would be a solution that would have some value over time, and people wouldn't have to be seeking out the newest miracle, getting every little thing they see on TV and the like. And I'll show you some amusing examples of those in the next class. Now, so just in that little quiz, you can see that you guys have varying levels of knowledge about nutrition, and some of this is important to your health and well-being, certainly to health and well-being of populations, so we need to know these. So first I'd like to start off with some definitions, and this is not the sort of thing that we're going to come back and quiz you on, so don't worry about the details here, but it's interesting how the field defines different terms. So food gets defined in the nutrition field as a substance that when eaten, digested, and absorbed provides at least one nutrient. Okay? Now remember the discussion we had in the very first class where I juxtaposed the picture of the flaming hot Cheetos and the cockroach. And we asked ourselves which one of these is food. Well, by this definition, they're both food. Now, people are beginning to question whether this should define what a food is. And if food is anything you eat, it gives you a nutrient, then basically everything satisfies the criteria for food. Not everything in the world, but most things would. But if we define food differently, that it's something that nurtures the body, something found in nature, something that doesn't harm the environment, there are a number of criteria one can apply to define a food. Then we might come up with a different definition than this. But this is the way the nutrition field generally looks at it. A nutrient is considered a substance within the food that's when it digested and absorbs, promotes some bodily function so that it has some metabolic health value when people consume it. And so the food is a broader constituent of what we consume. The nutrient will be the pieces of the food that affect bodily function. Nutrition is considered the process, the behavioral process by which people acquire nutrients and use them to promote vital activities. So nutrition is really what people are eating, and that overlaps with the concept of diet, which is when people are making specific choices about what to eat, how do they partition their nutrients? So do they eat a lot of carbs, a lot of fat, whatever they happen to eat? So those are the terms that get used a lot in the field. We'll more or less use these things interchangeably, but in some parts of the class, the distinction between nutrients and food is made quite distinct. And the person who does that best is Michael Pollan. And when you read his book, In Defense of Food, he spends some time in the book defining what food is and working through this quagmire of how do we define food and what's acceptable to eat, what's socially acceptable, what's personally acceptable. It's a very interesting discussion. But he also talks, and this is discussed in his book, about the concept of nutritionism. And what he proposes is that we have become so precise about nutrients and so concerned about the things that are in food, we've lost sense of what food is. And so fish doesn't become a food to eat because it's good for you. You eat it because it has omega-3s. It means that we supplement our diets with all sorts of things to fix perceived deficits in this mineral, in this vitamin, in this thing that somebody tells us is good for us. And because of this nutritionism, because of the reductionism where we have become so precise about what we eat in terms of its tiny constituents, that we've lost track of the bigger picture of food. And it's a very interesting argument and really does affect our relationship with food. So, how do we know what we eat? It becomes a very important question on a number of levels. Now here is the importance of assessing dietary behavior. And you guys are doing it on yourselves. And I do that very precisely because it'll teach you a little bit about how easy or difficult it is to do it and what kind of information you retrieve from a dietary assessment. So why is that important? Well, first, it is important because you need to track what the population is eating and also individual intake. These guys are just counting the number of people in the class for the registrar, so they're not doing anything more nefarious than that. Population intake. Okay, how do we know what to recommend to people to eat? How much vitamin A should they have? How many grams of carbohydrate or fat should go into a normal diet? Should people eat more of this food and less of this food? Well, the only way you know is to do studies, and we'll talk about how these are done in the next class, linking dietary behavior, food intake, with health. Well, that counts on your ability to accurately assess what people are eating or what the whole population is eating. And so measuring population intake is incredibly important to dietary recommendations. And people are very affected by these. They affect not only public policy, but they affect the way the food industry behaves. We'll talk later about the politics of food and how the food industry was very influential in getting the government to allow them to make health claims on cereals. So I'll have an ad I'll show you later in the class for Honey Nut Cheerios, where people are talking about how they're having to suffer by eating Honey Nut Cheerios to lower their cholesterol level. Well, and so it's sort of tongue-in-cheek, this is really good, I love to eat this, but yeah, I'm doing it because it's good for me, is the message there. Well, that's a health claim. That's a very specific health claim that company is making, that eating Honey Nut Cheerios will allow you to reduce your cholesterol. Well, there are politics that go into that company's ability to make that claim, but the fact that reducing cholesterol is considered good for you in the first place depends on these kind of studies on population intake to know how much cholesterol people are eating and then link it to reports of heart disease or cancer or whatever the health outcome is. Because of that, the accuracy of these records becomes very important. And then, of course, it's important at the individual level. Okay, just say that you're wanting to change your own diet to improve your health, or a physician has recommended that you do that. Well, in order to know how to change it, you have to know what it is, what it's like in the first place. And so somebody will ask you to do a dietary survey, pretty much like you're doing now, and then do an analysis of that and say, well, you should eat more of this and less of that, and why don't you try this food or that food, prepared this way or that way. But that's all based on how accurate your records are in the first place. So doing a dietary assessment is really important to individuals and to the nation and to the world when we think about health consequences. So how do we go about measuring these things, and what sorts of errors are in them, and how accurate are they? Well, there are methods that get used to track population intake and methods to track individual food intake, and let's talk about each of them. First, to measure what a whole population eats. How in the world could you know that? How in the world could you know how much beef the United States consumes? Or how many carrots? Or how many bowls of Wheaties? How in the world would you know this? Well, there are pretty gross ways of estimating these things that typically get used. One is to look at how much of these foods are produced. You can take commercial foods like Wheaties and go to the manufacturer and try to figure out how many boxes of these things are produced. You figure that most of those boxes are being eaten by somebody or another. There's some waste that you might calculate in, but error gets introduced there, trying to estimate that. But so you get a number on that. Okay? Then you can look at how many things like cows are raised in the United States, and how many acres there are of carrots or wheat or corn or whatever it is. And then you figure, well, some of that goes into food, some of it goes into other kinds of products. You have to make those calculations, and there are errors in that. But you come away with a population estimate of things like that. And then you can look at food disappearance data, and that's a sort of a connection with the food production data. Not so much how much is produced, but how much of it is disappearing from the food supply. That is, how many hamburgers do we think are being eaten, and that's the food's disappearing? How much of the foods are being consumed in processed products and the like. So that's a pretty gross estimate as well. And the other thing you can do is take self-reports like the ones you're doing, hopefully do enough of them and a random enough sample of the population that you can extrapolate from that sample to the whole population and try to estimate what people are eating that way. But of course that depends on the accuracy of the self-reports that people are making on their own. And as you'll see in just a minute, there are errors in that, and some of you may have experienced some of that yourself in keeping the dietary records. So, now how important is this? Well, I'll give you an example. There was a very big, one of the largest clinical trials that the US government ever did was called the Women's Health Initiative. And there were several purposes built into this particular study, but what it did was it took postmenopausal women and randomly assigned them to different dietary conditions. And one of the hypotheses that was being tested in this particular study was that a low-fat diet would reduce a woman's risk for breast cancer. So, you know, tens or hundreds of millions of dollars would go into a study like this by the time it was completed, money that could have been used for other things to test whether eating a low-fat diet would reduce risk for breast cancer. An important idea, to be sure. Breast cancer, a major killer, a major concern to women. At this point, the study had been undertaken. There had been many, many more trials that had been done on cancer in men than there had been done on cancer in women, so there was a political reason for doing it as well. But the hypothesis was based on this association, more or less, that looked at the rates of breast cancer across different countries and how much dietary fat those countries consume. And so you get a nice little scatter plot. On one axis you have dietary fat, the other you have how much, in fact I should have brought the graph but I didn't, how much breast cancer there is in the society. And you don't get a complete straight line, but you get an interesting function that suggests that there's a relationship. But all that depends on our ability to estimate dietary fat. And if our estimates are off, then the hypothesis makes no sense. That maybe there's no relationship between dietary fat and breast cancer. So we'll talk later about that particular study and what it found. When we talk about methods to track individual food intake, there are different ways of doing this, different methods that get used, and they have different levels of accuracy. But these are the most common ones. One is called the 24-hour recall. And that's either done by a computer or done by a trained interviewer who would sit down with you and say, let's reconstruct everything you've eaten in the last 24 hours. And so then you have to recollect everything that you ate in the last 24 hours. And you have to remember each of the foods you've eaten and their amounts. And in some cases, how they're prepared, like if you had potatoes, for example, were they fried or baked or eaten in some other form. All right, now you can begin to see the kinds of errors that this method might produce because people forget, they can't remember exactly how much they ate of things, or they may not be willing to disclose everything they ate. So for all these reasons, there's some error in this kind of thing. A food frequency, no, and by the way, you also have the issue of whether the particular 24 hours that a person is interviewed is representative of their diet overall. Because you can imagine how much your food intake varies from day to day. There will be days when you're very busy, you don't have time to eat, and your food intake is lower than normal. Other days you have more normal intake, or you might be making up for the deficit the previous day and you might have more. And so which of those particular days gets chosen determines a lot on inferences made about a person's overall diet. So what researchers do is they hope to get enough people in a sample where overall you hope to be capturing normal intake. One person might be a little low one day, another person might be high. A lot of people you might happen to have captured them on an average day, but overall it averages out so you get a representative sample. That's the hope, but of course there's still error in that. Okay, the diet diary, the food frequency is a different kind of questionnaire. That's where you're just asked over a period of time how often you eat this list of foods, and you're given a very long list of foods. So how often do you drink sugared beverages? How often do you have this kind of cereal? How often do you have this kind of fruit or vegetable? And you check the frequency, and then the inferences are made about your overall intake from that. That's a commonly done one too. A diary is another method. That's what you're doing now. You're essentially doing a diary. You're keeping track of what you're eating. Now hopefully you're keeping a sheet of paper with you and you're writing down what you eat so you don't forget everything, and then you sit down at your computer at the end of the day and you log it all in. Now my guess is that only a fraction of you are really doing that. That's the hope. If this were a scientific study, I would be instructing you to do that so you wouldn't forget anything by the end of the day. But most people say, well, that's a pain in the neck, or I forgot to bring the paper today, or I forgot when I had lunch to write down what I ate. And then you go back at the end of the day and you try to reconstruct it. Well, that's better than nothing, but again, there's error built into that. But the diary is a way to get more sophisticated information on individuals for dietary counseling purposes and the like, but it's pretty labor intensive, and then it requires either a computer to analyze the diet or some human being who's trained in this to sit down and make sense of the data. And so as a consequence, the diary measures have their own sets of flaws that we'll talk about in a minute. Now the hope is that someday there will be a biological measure of what people are eating. Now we have very good biological measures of some things. If we want to know your blood pressure, you put on the cuff, you've got a measure. We want to know your cholesterol, you do a blood test, you get cholesterol. So there are tests for a lot of different things. And those have been major advances in science and health. However, for dietary intake, there have been fewer advances like that because it's such a difficult thing to get a hold of. Now, Susan Main, who is a professor here in the School of Public Health, has done some very interesting work with an electronic device that can be passed over the palm of your hand and measures pigmentation in the hand as a way to assess vegetable intake in people. And this is very interesting, important work. And if this comes about, I mean, as the work on this becomes more and more robust and the measurement gets better and better, this will be a huge help because then we'll have a better sense of exactly what kind of things people are eating on the vegetable front. But of course that leaves all sorts of other foods as well to take account of. But those are the kind of advances we need. Okay, so how can accuracy be a problem? Well, we've talked about some of these already, but there are a ton of ways that inaccuracy can get introduced and when you start assessing what people are eating. And each time one of these errors occurs, or you get multiple errors that compound each other, then you've got a lot of potential error introduced in these messages. Okay, first of all, because everything relies on self-report, there's no machine, for the most part, that can do objective measures of this. You don't really know when people are telling you what they're eating. So that becomes an issue. And even if people are doing these things anonymously, or they're part of a big national sample where they're one of thousands and thousands of subjects, people don't necessarily like to say that they're doing something that they don't think they should be doing. And so people just not giving accurate information is one problem. Second is that people may not remember exactly how much they had or every little thing they had. That becomes a problem, and you may have experienced some of that yourself. Like if you're one of the people who hasn't been writing down things as you go along, and then you enter things at the end of the day, and I suspect that's the majority of you, you may have entered things into your record and then later gone and say, oh, I forgot, I had this thing. And so that not remembering becomes a problem. And then a variant, by the way, of number one, the falsifying things, is whether the record keeping itself is reactive. That is, do people change their diets because they're keeping track of it? Now let me get a little show of hands on this. Now when I asked you to start keeping the dietary records, I asked you not necessarily to change your food intake, because we wanted you to have an accurate record of what you typically ate. But did anybody have the temptation at all, and maybe even yielded to it, to eat differently the day you're keeping a record, so that you look good to yourself or to whoever grades those? How many people would say that's an issue? Okay, now that's a lot of people in the class, maybe a third or a quarter or half, something like that, a lot of people in the class. So it's not because you have malicious intent, but if our purpose was to get an accurate assessment of what you're eating, and even given my instruction to try to eat as normally as you can, there's still this propensity for the record keeping itself to be reactive, to have an effect on the very thing it's measuring. It's very difficult to estimate portions. If you go to the dining hall, the portions, one person serves themselves this much of a food and another serves themselves another, and then when you go to a restaurant, there are variations in how much you get served of things. And so it's very hard to estimate portions for people. And also, as I'll discuss in a minute, a lot of people don't recognize what a portion is. And because the food industry has been very successful at recalibrating us to think about what's acceptable to eat in one sitting at one time. And because of that, our notions of portions have been thrown way off. Second is a given food may vary. Just take a steak, for example, or some nice piece of meat at a restaurant. The fat content will vary a lot, and hence the calories will vary a lot. So 3 ounces of meat might have X calories, or it might have Y calories, depending on what the meat is. And of course, how much salad dressing gets thrown on a salad, how much of this gets or that gets put in a food will vary its calorie content a lot. And then of course some foods are pretty difficult to deconstruct if they're concoctions of foods. A lot of you, I imagine, make yourself kind of a salad at a salad bar. Well, how in the world do you know how many chickpeas you put in? And how do you remember later on how many tomatoes went into the salad? And if they're a pre-made salad, then it would be even more difficult because you're not constructing it yourself. So it's hard to guess based on these sort of things. And as a consequence, there's a lot of variability and error in these dietary measurements. And any one of these things would introduce error, but when you start adding them all together, you get considerable error. So that means it shows several things. One is how important it is to have more accurate measurement, and how important it is for scientists to get a better handle on what people are eating. And scientists have been working on this for years, and there's been progress, but it's still a very difficult challenge. And second, it shows that it weakens to some extent how much faith we can have in studies that link diet to health because of this error that gets introduced. Now we have to, we want dietary information, we want the information from these studies, so we take what we get and make the best use of it we can, but there are weaknesses in these kinds of studies. And then also a problem is you can't weigh things when you're eating out. So even if you were being incredibly precise about stuff, at home and you were actually weighing things. You couldn't do that very well when you're eating out. Now here's how the kind of errors that people make. I mean, it's pretty easy to measure errors in some cases. For example, you can bring people into a lab or something like that and show them food and say, well, can you estimate how many calories are in this? And then you actually know how many calories are in it and you get the error. And so way back in 1982, we did a study on this. And then I'm going to show you some similar studies that have been done in subsequent years to show you how much the error is. So in this particular study, we took 30 people who were entering a weight loss clinic, and we had them estimate the calories in these sort of common foods. So we actually had the foods on a plate or in a bowl or in a glass, and we asked them to estimate how much of the food there was, how many ounces they were seeing, and then how many calories there were. And again, there are no tricky foods here. These are all pretty common things. And here are some of the errors. So this is the percent error. And what you see here is that if the number is below the 0 line, it means people underestimated the calories. And the bars that go above means people overestimated the calories. Now, this is a little counterintuitive because very often people underestimate the amount of calories in things. But what's important here is the error, the size of the error. And in this particular study, we had some people estimate things low and some people estimate things high. But overall, these would represent overestimates. So in this case, people, bread, chips, and ham, they were estimating really, really large errors here. They were off by quite a lot. And again, you can't even correct for it because let's just say the whole population overestimated calories and things or underestimated by 30%. Well, then you just put in that correction and you know what you got. But people are all over the map, people low, people high, and things like that. So if you take people coming out of a McDonald's today and you ask them how many calories are in that meal you just had, and let's just say the meal was really 1,500 calories, you get some people who have no concept of a calorie at all and they might say 30 and somebody else might say 8,000. And so the variation is really enormous with this. And then if you go on to some of the other foods in here, you see that the error became even greater in some of these cases. Now this was 1982, quite a long time ago, at a time when people really weren't paying much attention to calories like they are now. So you'd expect the errors to decline as time goes on, and there's some evidence of that, but there are errors nonetheless. And by the way, here's where the average errors in this particular study. The average person overestimated calories by 53%, and we're very bad at estimating the quantity of things. And both are now, and so when you're doing the dietary records that you guys are doing, as an example, you don't have to calculate calories because the computer does that for you, but you do have to estimate the quantity. And if people are making errors of this magnitude, you can see the problem. Now here's a study that was done 10 years later in 1992. In this case, it was with obese subjects. Now, people are studying obese subjects because there are weight loss programs like the one we had and the subjects are available, but also you'd think that if there was a group of people that really had been attending the calories, it would be this group because very few people who come in for weight loss are doing it for the first time. And so almost everybody has been on lots of different dietary attempts and somewhere along the line they've been doing calories. So you'd think that this group would be a little more accurate than others. But what this study found was people were asked to estimate how much food they were consuming and how many calories they were burning through physical activity. And then the investigators actually measured these things and found that with reported and actual energy intake, how many calories people were consuming, there was really quite a difference. That the people were reporting consuming 1,200 calories or something, but when their food intake was actually measured, it was over 2,000 calories. So that's a big percentage error here. And it was in the people's favor. I mean, they were underestimating the amount they were eating, so it made them look better than they were actually doing. And in the case of energy expenditure, how many calories people were burning, there wasn't quite such a difference, but again, it was in the favor of the individuals that the people were estimating they burned this many calories from physical activity, but this is actually the number that they burned. Now here, they weren't estimating the calories, they were just doing reports of how much physical activity they got, and then the investigators calculated the calories. But and then the graph was created here. So you can see there are errors for both of these things. In one case, overestimates, and the other case, underestimates. And then the most surprising thing of all was a study done not long ago, published in 1997, of registered dietitians. So registered dietitians, and these are folks that are trained in nutrition. They're the ones who are certified to know a lot about nutrition. They do dietary counseling with individuals for the most part, telling them about portions and calories and nutrients and things like that. So you'd think these folks would know a lot, but they were asked to estimate the calories in, again, common foods. You know, lasagna, hamburger with onion rings, tuna sandwich, etc. And what they found was they underestimated by 200 to 600 calories the calories in these foods. So again, you get a sense of how complicated this is. If even the dietitians can't do it accurately, what in the world is the average person going to do? So a lot of our science rests on data that is flawed in some ways because of the difficulties in assessing what people eat. One problem that people have is understanding what a portion is, because you say we should have this many servings of fruits and vegetables a day, we should have this many servings of that a day. Well, what is a serving? What is a portion of things? And people really are bad at guessing about this, and they become worse and worse. This hasn't really been studied, but my guess is they become worse and worse for the reason I mentioned before. When I talked in the first day of class about my own boyhood experience when a Coca-Cola was an 8-ounce glass, or a Pepsi was an 8-ounce bottle rather, that was a serving. And so when it was time to have a Coke or a Pepsi, you had 8 ounces and then you were considered done. You know, not that you needed more, you had to finish anything else because you'd already finished it. But now, if you have a 20-ounce bottle, your cue for when the drinking event ends is completely different than when I was a child. And it's 2.5 times different than when I was a child. And so people have become calibrated to what different sizes are. And as we'll discuss later, the language that gets used with these things is very interesting. What used to be a large French fry at McDonald's is now the small French fries. And so, a lot of people will order something, like they'll go to a restaurant and they'll say, well, would you like small, medium, or large? And people would say, well, I'm kind of an average person, I'll have medium. But medium today is not what medium used to be. And because of that, people really make a lot of errors in understanding how much a portion is. And so here are some examples. For example, a portion of pasta, according to the US Department of Agriculture, would be about the amount of pasta that would be the size of a tennis ball. Now that's not a lot of pasta, but that's considered a serving. Now, if we had the time to do this, and before I had mentioned this to you, if we'd brought you guys all in to a laboratory or something, or a kitchen or whatever, and given you a big pot of pasta and said, please take out what you think a serving of pasta is, my guess is that many of you would have done more than a tennis ball amount of pasta. In some cases, many times more. And then if you look at what's served in restaurants, like if you go to the Olive Garden or the Macaroni Grill or these sort of things, you get portions that are, multiples of this kind of thing. And you see this kind of idea about what pasta might be like. Cereal would be, a serving of cereal would be about the amount that would fit in a wine glass. Okay, but people think that you fill up a bowl and that becomes a serving. But a typical amount of cereal that people serve themselves might be 2 or 3 times what the ordinary size is. Now that's okay as long as you understand what's going on and it's reasonable for your health. The amount of meat or fish that constitutes a serving is the size of a deck of playing cards or a bar of soap. But when you go to restaurants or people buy steaks, you just don't see anything that small. And so the serving sizes are multiples of what might be typical. A pancake is 3 inches in diameter. one serving of pancake is 3 inches in diameter. Now, take your hands and, kind of do that, and you can get a sense of how small that really might be. But when people eat pancakes, it may not be this extreme, but still, there are a lot of things where the portion sizes are misestimated. Now, here's another example. A bagel, a reasonable sized bagel that's a serving size is the size of a hockey puck. So again, what hockey puck is this big? Well, you just cannot find bagels that small. I mean, if you went looking for them, you would have trouble finding one that small. And so when you get a bagel, it used to be you'd get something this size, and now you get something that's really, really much bigger. And as a consequence, and there's of course stuff on them and in them that changes the calories. A muffin, serving size is the size of a light bulb. Well, it's very hard to find muffins that size. Certainly if you buy them out somewhere, you're going to get one that's maybe the size of a light bulb, but it's like the floodlight in your backyard or something. It's a huge light. And of course, then there's the extreme bagel that you see here. So portions are an interesting phenomenon, and people estimate these in different ways. Okay, so let's talk about foods and what comes in them and what they deliver to you. So let's take grapes on the right and French fries on the left. Well, both are foods, depending on your definition, but both are foods. Both have nutrients. Both have things your body can make use of. Both have calories and energy. But they're, of course, much different from one another in how they affect people and what they do for a person's health. So let's walk through this a little bit. Let's first talk about what a calorie is. Okay, now, most everybody understands the basic concept of what a calorie is. You eat food, it delivers something that can affect your weight, and that something is divided into units called calories. But it's interesting to go a little further and think actually about what that concept means and where it comes from. So calories are a unit of energy. And you can use this, I mean, you could calculate the amount of energy available in a lot of things, not just food, but in oil, let's say. You could calculate the amount of heat that you can produce from oil, and that could be measured in calories if you wish to do it. But people usually apply it to food. So it's the amount of energy, usable energy for the body that a food provides. And if we look at two different foods here, broccoli and the brownie on the right, they're of course much different in calories, but they're different in other ways. So they deliver different amounts of energy, and they also deliver different amounts of nutrients. But we'll talk about the energy for the moment. So if you were starving and you really needed energy, that is, your body needed calories, it needed usable energy in order to survive, the broccoli is not going to do you much good, and the brownie would be terrific. But if you have enough energy, or you have too much energy stored in your body and body fat, then the brownie's not such a good idea because it provides too much. And of course, not nearly the nutrients that the broccoli would provide. So how do we measure calories? Well, a calorie technically, and this is again not something that we would ever quiz you on, but I just thought you might be interested to know, that it's the energy required to raise 1 gram of water 1 degree centigrade. And we'll talk in a minute about how you might go about measuring that. A kilocalorie, and this is really what when people talk about calories, how many calories in food, it's really kilocalories that they're referring to. But that would be the energy required to raise a kilogram of water 1 degree centigrade. Now, how do you measure this? How do you know what foods are in calories? Well, what you do is you bomb the food. And you use something called a bomb calorimeter that looks like this. And so essentially what you do is you put the food in this device that sits inside water. You ignite the food and burn it, and you see how many degrees centigrade the water gets raised. And that's the measure of calories. So if you were wanting a pretty precise number on how many calories are in a food, you'd send it to a lab, they would bomb it, they would burn it, they would put it in this container inside water and see how high the water temperature raised, and that would give you a sense of the number of calories that it has. So that's how we understand that concept. So how well can you estimate the calories and things? So let's just take a few examples. Okay, now if you guys are using your computer or you have a pen, I'd just like you to write down what your estimates are of a few foods I'll show you and see what you say. So how many calories and how much fat, how many grams of fat would you say are in the following foods? Okay, so a taco salad from On the Border. So just write it down. I'll give you the numbers in just a second. How many grams of fat would you say this has, and how many calories? On the Border is like a Mexican chain restaurant. Okay, so this is their grande taco salad. Okay, so if you've made your estimate, I'm going to show you the numbers now. So 1,450 calories and 102 grams of fat. Now, you know, you go to a Mexican restaurant, and if you want to be virtuous, you have the salad. But, you know, sometimes what seems to be the virtuous choice may not necessarily be. So that would be an example. Okay, let's take another one. Okay, Chili's chocolate chip paradise pie with ice cream. How many of you haven't had breakfast and are getting incredibly hungry by seeing these pictures? There you go. Okay, well, I hope you don't rush out of here and go for the paradise pie. All right, how many calories and how many grams of fat? Oh, by the way, for the grande salad, how many of you underestimated the calories in that? Okay, almost everybody did. Okay. All right, so have you got your estimates? Grams of fat and calories. Okay, here's the answer, 1,678 grams of fat. Okay, here's another one. See, this is testing your restraint, because of those of you who have willpower will stay for the rest of the class. The rest of you will flee the room and go to Starbucks right up on the corner and get something like this. Okay, so the venti size Starbucks strawberries and cream frappuccino. Pardon me? With whipped cream. You must be pretty good at estimating calories if you asked that. Okay, so here are the numbers. 750 and 15 grams of fat. All right, let's do one more. Now, this, by the way, would probably look more appealing if you were in the restaurant, but somebody took a photograph. They got the carry-out version of it, took a photograph, and it doesn't look so hot. But this is from the Outback Steakhouse, Aussie cheese fries with ranch dressing. How many calories and how many grams of fat? Okay, here's the answer. 182 grams of fat. All right, now what I'd like you to do is just sort of do a guesstimate in your mind of the percentage errors you might have made overall in these estimates. And I'll come back and ask you in a minute. But how many of you were pretty consistent in underestimating the calories? Okay, nearly everybody was. Okay, so we get surprised when we see these things. Okay, how many people would say they were off by an average of 0 to 10%? Okay, so not one person in this class Highly educated people, a lot of you probably care a lot about food, think about labels, read them and things like that. Not one person out of the 300, 350 people in this room guessed correctly within 10% margin of error. How many of you would say you were between 10% and 50% off? Okay, some. How many would have been between 50 and 100% off? Okay, so you can see the size of the errors, and you can see the problem with dietary assessment, and you can see the problem with how many calories get packed in processed foods. And when you start jamming sugar and fat into things, the calories add up really fast. Now let's take this information and put it in the context of what a day's fat and calorie intake might be like. So the average person, average normal weight, typical person might consume 2,000 calories a day. Now there's a lot of variation in that. Men would be different from women, taller more than shorter, all that sort of thing. But nonetheless, let's just use that as a reference. Now, the government recommends that people have less than 65 grams of fat per day. If we look at our different foods and we look at the calories and the fat and how it all stacks up, here's what you get. So the 65 grams of fat gets used up pretty quickly, doesn't it? And if you think about the percentage of a day's calories of these things are, the numbers are really pretty high. So it's very easy for people to exceed dietary recommendations given what the modern food supply is. Now, if you lived in a culture where the only meat that got served was the size of a deck of cards, and the only pasta that got served was the size of a tennis ball, there wouldn't be such problems. But that's not the case. And so what people should eat and what people think they're eating and what they actually eat is really much different. And that leads to all kinds of problems. Now, let's talk about nutrients. Nutrients get broken down into several classes. And these are the constituents of food that your body uses for one purpose or another. And there are macronutrients and micronutrients. And you've heard of both. The macronutrients are the big constituents of food. That's protein, carbohydrate, and fat. And I'll talk today about protein, and then next week or next class, we'll talk in more detail about carbohydrate and fat. And all are extremely important to the diets of Americans and diets anywhere in the world, and are very interesting. The micronutrients, which are available in food but in smaller amounts, are vitamins, minerals, and water. Okay, so the macronutrients, protein, carbohydrate, and fat. The micronutrients, vitamins, minerals, and water. The macronutrients, the big three, protein, carbohydrate, and fat, is what people think about a lot when they eat. Because most people are thinking, well, grams of carbs or grams of fat and things like that. Am I eating enough protein today? And they're not thinking about zinc and phosphorus and potassium, which would be the micronutrients. And so these are the things people care about a lot, and they're the ones that popular diet books are built around almost exclusively. That you should eat low fat, you should eat low carbs, high fat. There are all kinds of permutations of these that exist out there. As we mentioned in one of the earlier classes, these macronutrients differ in how much energy you can derive from them. And protein and carbohydrate have 4 calories per gram per unit weight. Fat has more than twice that. So fat becomes a very valuable energy source. Gram for gram, it provides a lot more punch in terms of calories than protein or carbohydrate. And that could be why fat has such an appeal to human physiology and why people like high-fat foods. And those video clips I showed in the last class were evidence of that, where they talked about the sensual properties of fat. They showed the vats of chocolate where people were stirring it and things. And those evoke a lot of interesting sensations in people, a lot of interesting reactions in people, because fat is inherently tasting good to us because there's reason for it to taste good, because it provides so many calories. So as I said, we'll talk about protein this week a little bit and then fats and carbs next week. And I'm not going to get into this in too much detail because we don't have the time. There are other places where you can read about it if you're interested. But I'll just give you a little information on this. Protein in the diet is valuable for a number of different reasons. And there are a number of diets, almost all diets will urge people to take in enough protein. And so the amount of protein in the diet from diet plan to diet plan doesn't vary as much as the recommendations that these popular diets give you for fat and carbohydrate. But it's very important because it does provide energy, but it helps with muscle building and with the manufacturing the body does of its own proteins, and therefore is a vital part of the diet. There are sources of protein, and this may not surprise you, are multiple, and they come in these various sources. These are all good sources of protein, but not the only ones. And so if one is looking to keep protein at a certain level, then these sort of foods would get favored. Most people in America would get enough protein if they're eating a healthy, balanced diet and wouldn't have to pay so much attention to protein in particular, but not everybody is getting a healthy, balanced diet, so it is important for people to pay attention to this. Now, moving on to the micronutrients, the vitamins and minerals and water. These become pretty interesting. They appear in food in pretty small amounts, which is why they're the micronutrients, but they're vital for health. And so if you're deficient in micronutrients, you've got big problems. This is less of a problem in modern life than it used to be, but because things are supplemented and fortified, overly so in some cases, but still the deficiencies are less common than they used to be. But these are things that must be taken in from the environment because your body cannot manufacture them, and they promote specific chemical reactions in the body. And so the micronutrients the vitamins part of the micronutrients would fall into several categories. There are water-soluble and fat-soluble vitamins that look like this. And the difference between the two is that the fat-soluble vitamins, when they're ingested, get stored in the body fat, primarily in the liver. And as a consequence, the body can draw on these stores. There can be a supply of them, a storehouse of them that can build up in the body. And so day-to-day fluctuations become less of a problem with fat-soluble than water-soluble vitamins because the body can go grab them from a storage depot, if you will. But then they can also be toxic if taken in too large of amounts because the body does store them. The water-soluble vitamins tend to be used more immediately by the body, not stored and excreted through the urine if consumed in excess. So the body can tolerate more variation in intake of these before you start getting toxicity than is the case with the vitamins on the right. But they're all important for health in one reason or another. And again, we could spend a lot of class time saying, well, riboflavin does this for the body and that for the body, but my guess is most of you wouldn't find that so interesting. And for those of you who would, their information on it is available elsewhere, as I said. The minerals are present in small amounts in food and as a function of body weight as well. And they would be things like calcium, phosphorus, potassium, sodium, etc. The ones that get talked about the most in terms of health, the one is sodium, of course, because of salt intake, but the others are important for health as well. In some cases, they're being consumed in large amounts and some in small amounts. And there are very important public health victories that have occurred along the way with supplementation of these sort of things. So iodine deficiency was a real problem, and then salt started getting fortified with iodine, and that really corrected a lot of those deficiency problems around the world. And so there are good things you can do with nutrients by fortifying foods with them, but of course there can be abuse of these when the food industry puts stuff in foods that doesn't really need to be there, and then they overstate the value of them. And we'll talk about that and what's reasonable and what's not as we go through the class. Water, of course, is very important. You know, our relationship with water has changed a lot too, and a lot of that is due to marketing. It used to be the case that well, I mean, my guess is that very few of you probably go through a day without interacting with a water bottle at some point. And in fact, I do this as well. I mean, I have water with me, and I have no idea why, because I'm not particularly dehydrated, but people think they need to have water with them all the time. And if I think back to my own childhood again, not that that was the glory days by any means, but I mean, people weren't falling over hour after hour from dehydration because they didn't have a water bottle with them. But we've been so completely socialized into thinking two things. One is that we need water with us all the time, and second, we have to buy it. That creates all sorts of social consequences that we'll talk about. Sustainability with shipping water long distances, all the plastic involved, people's distrust of public water systems that's unfounded and things like that are very interesting, and they have big public health consequences. And elsewhere in the world, water becomes a major, major issue. But of course, it's important to health and you need enough of it. So when we think about what we eat, we can compare what people eat compared to dietary recommendations. And the government has a very complex set of dietary recommendations, 41 of them altogether in the most recent version of this. In 2000, there were only 10, but so the number has gone way up. And as we'll talk about when we get into the politics of foods, what is recommended for you to eat is very heavily influenced by the industry. The industry exerts its influence in a number of interesting ways that we'll discuss. But when you're told you should have so many servings of dairy a day, don't believe for a second that that's based only on scientific information, because the food industry is a big player in how these national recommendations get established. But given that, they're about the best we have and our best judge about what people might eat. And we'll talk later about the construction of the food guide pyramid. This is the most recent version of this. And we'll talk about whether this graphic makes sense to people, whether it's the kind of information people can access and make use of, whether people even pay attention to it or know about it. We'll talk a lot about that because it says a great deal about the way our government deals with nutrition issues. But the current pyramid makes the diet look like this. It shows several things. One is that you're supposed to eat a variety of foods, and then the foods are put into different sized triangles here, depending on how much of them you should be eating. So the grains in the orange side, you're supposed to be eating more of those than what might be a smaller slice of the pie here, or the triangle. And so people who see this are expected to be able to make dietary choices based on this. And then a new addition to this as well is the fact that you see the figure climbing the stairs, which connotes the importance of physical activity. So this is a general sense of what dietary guidelines of the United States are. This is what people are being told they should eat. But in fact, the vast majority of Americans do not meet dietary recommendations. And so this is the percent of Americans meeting dietary recommendations, and the dotted yellow line represents things on the left-hand side where people are eating too little of a particular thing, and then on the right, it's the percentage of people, well, it's all across, it's a percentage of people who are eating the recommended amount. But in the case to the left of the line, people are eating less than they should, and to the right, they're eating more than they should. So for example, the bar to the far left, the grains, shows that 24% of Americans are eating the recommended amount of grains. 28%, only 28%, are eating the recommended amount of vegetables. So this is a pretty discouraging number. And then you look at, to the right of the line, with meat, for example, only 30% of people are eating the recommended amount of meat. The rest are eating too much. The total fat, only 38% of people are eating the recommended amount of fat. The rest are eating too much. So that's how you get a sense of these numbers. But in all cases, these are significant variations from what the recommended dietary intake should be. And this would suggest, if you see this, to the extent that these things along the bottom are relevant to health, and they certainly are. I mean, everybody would agree with that, and we'll talk about some of the information on that in the next class. But to the extent those are relevant to health, the fact that we're so far off from the dietary recommendations is cause for great alarm. Something terrible has happened with the American diet. And it's not just happened in America, but country after country after country is changing to follow America's example. And so we'll loop back as we go through the class to questions about what's gone so horribly wrong, and more important from a public health point of view, what can be done about it. So we'll talk about what individuals can do, what a country can do, what the world can do to help change what are really pretty discouraging numbers. This graph shows some of it as well, but in this case for children, in the left-hand side you see the ideal composition of a diet according to government recommendations that the diet should be partitioned in this way. And then the next slide shows the average reported intake of 10-year-olds in the United States. And you can see the pie charts don't line up very well. And if you look at certain parts of this, like fat and added sugar, you have 5% is the recommended amount of sugar and fat added to food, but the actual amount is between the sugar and the fat put together is 48%. What a huge discrepancy there. And so these numbers are very discouraging. And then things like grain, the children are eating less than they should. Now the question is, what are people eating too much of? And are there certain parts of the diet that should be the focus of our concern? Well, that Jenkins article that was part of the reading today discussed that issue. Are people eating too much of everything, or are they eating too much of certain things? Well, Jenkins makes the argument that people are eating too much of everything, and that every part of the diet is being overconsumed, and except for things like fiber, which is being underconsumed, but every sort of thing that people should be eating less of is being overconsumed. And so focusing on one nutrient is a losing proposition according to some people. But there are others who say that nope, some nutrients prevail over others and are highly important compared to other things that you might be concerned with. And Atkins' diet is an example of that. And so, you know, a lot of you were forming ideas about food and nutrition during the Atkins craze. And my guess is a lot of you care a lot about carbs in the diet. Pay attention to them, look at labels about carbs and things like that. And if you bought into the Atkins philosophy, it means that you're less concerned about fat than you are about carbs. In the fact it's okay to eat a lot of fat as long as the carb intake is reasonable. That's the philosophy. So does that make sense? Is that a reasonable way to approach the world? Well, we will find out. And we'll talk about that in the next class. Now, before you guys go, there's one more thing I wanted to mention, and then I'll show today's comedy clip, which is a good one, by the way. They're all good, but this one's especially good. Our Rudd Center website, which is www.yaleruddcenter.org, we have recorded a series of podcasts with people who have visited the Rudd Center, and I would urge you to listen to those. And I'll be mentioning these as we go throughout the class. So for example, we've had economists visit, and when we do the class on economics, I'll urge you to listen to that particular podcast. But there's one in particular that you just have to listen to. And it was the interview with Michael Pollan, the author of the book that's for the class. And it's really a terrific podcast, and he was a great guest. So please go to our website and listen to that.